Okay, so now we're doing dun 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 lesson 4. Lesson 4. This is math 20-3, and we're talking today about the volume of pyramids and cones. So earlier we did the surface area of pyramids and cones, and now we're going to do the volume of pyramids and cones. Remember when we did the volume of any prism or cylinder, the volume was the area of the base times the height. So base times height. So if we had a rectangular prism, it was base times height, and the base was length times width times height. If we had a cylinder, it was area of the base times the height, and the area of the base, because it was a cylinder, was pi r squared times the height. Now the cool thing, and if we were in person in class, we'd do a neat little activity where we could fill these shapes with water, and we'd find that if we have a pyramid with the same base as a prism, I can fill it 3 times with water and pour it into the prism. And so basically the pyramid takes up 1/3 the space. So the volume of a pyramid or a cone, the same thing happens with a cone, is the area of the base times the height, not the slant height, but the actual vertical height, divided by 3. So it'd be base times height over 3. Basically, you need 3 pyramids to fill a prism with the same base. And the same thing happens with a cone. So I can also write this as, if I'm dealing with a rectangular pyramid or a square pyramid, it's going to be length times width times height all over 3. So you know how I love a formula? Well, you get one. Now the same thing happens with a cone. The volume will be pi r squared h all over 3. You need 3 cones to fill up 1 cylinder. So it's nice. We're substituting into a formula, and you can have this formula on your formula sheet. Okay? So what we really need to figure out is the area of the base. We need to make sure we have our vertical height. Okay, so let's do some verkia. So looking at these 2 pairs of objects, if I have this prism, and look, they both have this prism and this pyramid have the exact same size base, because they're square prisms. It's a square prism and a square base prism and a square base pyramid. So coolio there. So for the prism, it would be length times width times height, which would be 6 times 6 times 8, because that's my height. So I get 288 centimeters cubed. For the pyramid, it's going to be length times width times height over 3. So it'll be 288 divided by 3. So my volume for the pyramid will be 96 centimeters cubed. So it's basically, you take the volume for the prism with the same base and you divide by 3. Something similar happens with our cylinder. Here we have a cylinder and a pyramid with the same base. So my base is this circle. It has a radius of 7 centimeters. So when I do the cylinder, it will be pi r squared h. So pi r is 7 squared times 12, and I will get 1847.26 centimeters cubed, because it's volume. Now for the pyramid, it's the exact same thing, except divide by 3. So the volume here, I'll take that 187.26, divide by 3, and for my volume, I will get 615.75 centimeters cubed. So basically, same base, going from cylinder to pyramid, it's just 1/3, okay? Oops, I meant to slide my page up. Oops, I meant to erase. So let's slide up. So let's do some examples just to get this practice. This is the kind of stuff I like because it is nice to have some examples, right? So we're going to calculate the volume for each object below. And look, we're going to round to the nearest hundredth. So we need to start practicing our rounding rules because some of us are not very good at that, okay? So here we have a square-based pyramid. Volume is base times height divided by 3. The base is length times width, so length times width times height over 3. So it will be 4 times 4, because this is the same size, times 5, all over 3. And for my volume, I will get 26.67 inches cubed. And look, I rounded it to the nearest hundredth. So remember, when you're rounding, you want to make sure that you're rounding to the correct decimal place. Let's do this cone here. Same thing. Volume is base times height divided by 3. And the base for a cone is pi r squared h over 3. Now this is our diameter, so our r will be 25 divided by 2, which is equal to, what is that? 25 divided by 2 is 12.5. You have to do it before you substitute it in, okay? So that will be pi 12.5 squared times our height, which is 40. When I multiply all of that, I get 6544.98 centimeters cubed. And I said to round to the nearest hundredth, so you need to make sure that you've done that, okay? Alrighty, let's see. What's next? Is there more examples? Well, that's basically it for examples. I can do some more if you'd like, but that'll give you some nice examples. I'm going to try and get both of these on the screen. It's fairly straightforward. We did a lot with volume with pyramids, with prisms and cylinders. So all you're doing is the exact same work except you're dividing by 3. And I forgot to write the divide by 3 there, so I'm sorry about that. But I did do it when I did the math. Oops. So that is the big difference, right? That it's a divide by 3 because it takes 3 of those to fit into the volume for a pyramid or a prism. Okay, so you have some extra practice to do, some nice practice with volume of pyramids and cones, and you have some worksheets. Please ask questions if you need to, but a lot of it is substitution. I like to, we're not doing it so much here, but sometimes you can make a list of what you know and then substitute in or circle